So, as a continuation from the last part that we had on our trigonometry, working with the reduction formula, remember we managed to have the reduction formula, but that reduction formula that we had, it was focusing, or it was a major concept on the positive angles. So as you consider your reduction formula in terms of the positive angles, I was saying these are the ones which are taken in the anti-clockwise direction. So any part that is in the anti-clockwise, these are positive. In the first quadrant, you're going to have your theta. This will be 180 degrees minus theta, 180 degrees plus theta, and here you've got 360 degrees minus theta in the fourth quadrant. These are the angles that we had as what? Positive angles. So these angles, in terms of their reduction, in terms of our reduction formula, it gives us the same properties as their equivalent negative angles. As their equivalent negative angles in the same quadrant. Meaning to say, as you have to consider, remember I was saying, guys, in each and every quadrant, there is what? There is a reference angle, which is what? Which is your this angle theta, an acute angle. Just consider that as our reference angle in each and every quadrant. So as negative angles now, how is this going to be presented as we consider negative angles? So as for negative angles, we are going to see that this time we are going to be considering our angles in the clockwise direction. The clockwise direction is the one that gives us negative angles. So negative angles will be taken clockwise. The normal way the clock moves, those are negative angles. So as you are considering, guys, remember that quadrant concept. In each and every quadrant, there's what? An acute angle which lies in that quadrant, which is taken between the horizontal and the line that we are given. So meaning to say, we've got our theta here, our theta, like that. So previously, we moved it in this way, all right? Because that is how we take our positive angles. So we are moving from the first quadrant up to the fourth. In this case, this is where we've got our 0 degrees. And we are saying negative angles are taken in the clockwise. So we are going to be focusing from the fourth quadrant, third quadrant, second quadrant, until we get to the first quadrant. So in actual sense, this angle that we are going to take from here to here, this is the angle that we are going to take as the actual. It was supposed to be just like theta, the way that we have there in the first quadrant. But because of the direction, it's taken as a negative angle. So this is going to be called minus theta. All right. This angle that we have from here up to here, remember, this is the angle that you're supposed to take, this one. It was supposed to be presented the same way as we have in the second quadrant. Remember the way that we move? We are moving this way. It was supposed to be, guys, the same way that you were moving here. It was supposed to be 180 minus theta, this one. But because of the direction, we cannot say this angle is 180 minus theta. It is just like this. I want you to understand this properly. It is just like this. It is just like this, guys. It is just like we are given an angle here, which is 150 degrees, which lies in the what? In the third quadrant. From this point to this point, you indicate on the diagram as 150 degrees. On the diagram, it is because already the arrow, the direction is telling us this angle is a negative. But as you are writing this angle, how do you write this angle? You write it as minus 150 degrees. But on the diagram, you present it what? As just 150. But that angle is negative 150. It's negative 150. It is the same presentation like what we had if it was in the what? in the second quadrant. In the second quadrant, we had an angle of positive 150. The direction, these are positive. This one, negative. That is the only part. So this is what I'm trying to say. If you know that this angle here, like this one, it was 150 degrees because of its direction. We are talking about the same presentation in terms of how big the angle is as we consider this side. Because this is where we have our theta. The same way, look at this gap, guys. We are talking about here. From this point up to this point, what is just missing is this theta here. Is indeed the same thing here from this point here up to this one. What is just missing is this theta here. So in terms of how big this angle, this one, and this angle, in terms of how big they are the same in terms of how big, but only that this one is carrying a negative, this one is carrying a positive. So if you understand this sense, guys, it is going to be easier for us because we are saying if an angle is lying in the second quadrant here, which is given as 180 degrees minus theta as a positive angle. What about when it is this side, which is taken as a negative angle? What are you going to do? We are simply going to take that as it is. We put a negative. Just like 150 as a positive, it's a numerical value, this one. So you just said, all right, the angle is 150. So let me multiply by what? By negative. You're done. But this one is 180 minus theta. So you're supposed to put a negative. We open the bracket. 180 minus theta. With this, guys, you won't even go wrong. So when you multiply by this negative, this is the angle, which is the same like what we have. 150 minus 150. So we can simplify negative times this. That's negative 180. Negative times this. That's a positive. So that's positive theta. So as we can see, we can even start with a positive value there. So we can start with what? Theta. So it's going to be theta minus 180. Theta minus 180. So it follows that in the third quadrant, remember, here we are moving this way. Here we are moving this way. So we are now in the third quadrant. It follows that as a negative angle, in the third quadrant, our angle is going to be given as what? Theta minus 180 or minus 180 plus theta. So this angle is theta minus 180 degrees. This is the angle that lies in the third quadrant as a negative angle. All right. So this is how you take your angle. If you understand this, guys, you won't even go wrong. You won't even go wrong. You won't even go wrong. Each and every angle, it has the same property. Look what happened in the first quadrant. The first quadrant, our angle is theta. Remember the way that we are moving. Here we are moving like this. This is the direction. All right. Let me present this way. This is our direction. This side, this is our direction. So as we have, guys, as we have in the first quadrant, as we have here in the first quadrant, it's theta positive. Same thing, but it is now in the fourth quadrant because we are moving this way. So we are starting, it's like 1, 2, 3, but that is not how we are counting to say this is now our first. No, I'm just saying it is like 1, 2, 3, 4. This is the way that you are moving, but the concept does not change to say this is our fourth quadrant, this is our third. I'm just saying in terms of how you move. Just like 1, 2, 3, 4. This is how you move. So you consider the same way. So what is happening in one of here as a positive angle is supposed to happen the same way as one of here as a what? As a negative angle. So you just put to say this one, it is theta. So here it will be minus theta. We move on to the second one. It's 180 minus theta, like this, 180 minus theta. So here we are moving like 1, 2. So we are now here. That angle there as a negative angle, you multiply it by negative, just like that. So it is going to give us minus 180 plus theta, which is theta minus 108. If you do this, guys, you won't even go wrong. All right. So you do the same thing. in the third quadrant of the positive angles, our angle is what? 180 degrees plus theta. We are talking of what? Positive angles. So what is going to happen? We are counting 1, 2, 3. Remember, we are in the third quadrant. So we are counting 1, 2, 3. So here we are in the 1, 2. Okay, sorry. This is 1, 2, 3. So the 3 lies in the second quadrant. We are talking about the angle that is going to lie in the second quadrant. It carries the same properties as the angle that we counted in 1, 2, 3 manner. In this one, 1, 2, 3. So the angle there is what? 180 plus theta. So it means here it is going to be what? A negative angle. Just like that. You multiply it by negative. So multiplying this by negative, that's going to be negative 180, negative times this, negative theta. So it means in the second quadrant of the negative angles, our angle is going to be written as minus 180 degrees minus theta. Or this one, guys, as you can see, both of them, they are positive. So we can even write it as what? As minus theta minus 180, no matter the way that it is given. It is one and the same thing. So that's how we write a negative angle of the second quadrant. So this is how you present your angles. So we move on, guys. The same way that we're counting, we said 1, 2, 3. Now we are in the fourth quadrant. In the fourth quadrant, the angle is 360 degrees minus theta of what? Of the positive angles. Here we are counting 1, 2, 3, 4. So our 4 lies in the first quadrant. So we're talking about the angle that is going to lie in the first quadrant. It carries the same properties as this angle in the fourth quadrant, because that is where our 4 lies. It lies in the fourth, in this direction. In this direction, our 4 lies where? In the first quadrant. So we're simply going to multiply by what? By a negative, because these are negative angles. Every negative angle, multiply by negative. So let's multiply. Negative times 360, that's negative 360. Negative times negative, that's positive theta. So it means our angle can be written as what? Starting with a positive, it's going to be theta minus 360 degrees. Theta minus 360. So it means the angle which lies in the first quadrant as a negative angle, it is called theta minus 360 degrees. That is the concept. Guys, you are supposed to, you see, the way that you know positive angles, if you know this part of your positive, you're done. So I said, this is how you take them, all right? You were moving this way because of the direction of what? Positive. Now you are moving this way. So you just interchange 1 of here. So it's just like 1, 2, 3, 4. So 1 of here corresponds to this one, but with a negative. The 2 of here corresponds with the 2 of here, but with what? A negative. The 3 of here corresponds with this one, but with what? A negative. The 4, the same thing. But do not forget your quadrants, the naming of your quadrants does not change. Please, there we are just doing it for us to get the sense of what is happening. But the naming of the quadrants does not change. What am I trying to say? The first quadrant remains the first quadrant, this one. The second quadrant is the second, always. The third is the third. The fourth is the fourth. There it was just the issue of the naming. So if you understand this, our conclusion now is that as positive angles, the way they gave us, the corresponding reduction angles are like, remember our reduction formula. It is the same thing even for the positive angles as long we are in the same quadrant. So what am I trying to say here? Remember our cast concept. This is our cast concept. All right, our cast concept. So what am I trying to say here is that if we see an angle of theta as a positive angle, all right, as we can see in the first quadrant, Let's talk about the first quadrant. You understand me here. First quadrant. So as we talk of the first quadrant, there are two things there. It's either it can be a positive angle or it can be a negative angle. Take note there. It can be what? A positive, it can be a negative. But the concept is the same. All right? The concept is the same. So for positive angles, this is the one that we talked about in our previous class. We're not going to waste much time. Negative angles. So remember, for our positive angles, guys, we listed all these reductions that we are going to have. And I said in the first quadrant, already, remember, reduction is used to reduce non-acute angles to any acute angle, non-acute. We are reducing non-acute. Here, this one. Used to reduce non-acute angles. Non-acute angles. All right. Non-acute angles to an acute angle. That is the concept. So in this case of the first quadrant, as a positive angle, the angle is already an acute angle. Remember, theta is an acute angle. Wherever we see our theta, theta is an what? Is an acute angle. Theta is an acute angle. Wherever we see theta in this presentation, it means an acute angle. So in the first quadrant, your angle is already theta as what? As of the positive angles. So it means there was nothing there. The sign of theta is there is nothing that we're going to talk about. We are not reducing anything there. So that is why we saw in our previous class, we never reduced anything in the first quadrant. We're talking about the second, third, and what? And the fourth. But as for the what? As for the negative angles, we have to reduce because it's written as what? Theta minus 360. Theta minus 360. So it means we can reduce this part. Remember, our concept is that from the cast concept, it is here, all of them, they are positive. Sine is positive, cos is all of them, sine, cos, and what? And tan. So it means whatever that we're going to have, the sine of what? Theta minus 360, because it lies in the first quadrant. It follows everything that the first quadrant has. So the sine of theta of theta minus 360 is going to be reduced to the sine of what? Of theta as a positive. In the first quadrant, all of them, they're positive. So it was the same thing, the cos of theta minus 360. It was still going to be a positive. So there, we have nothing much to talk about there. So let's just write this one. The tan also was going to be what? A positive, this one. All right, so this is it about the first quadrant. So as of the positive angles, as we can see, there's nothing that we're going to talk about there. But the angle that we'll be talking about here is what? Is theta as of the positive angles. As of the negative angles, our angle is referred as what? Theta minus what? 360 in the first quadrant. Our angle is theta minus 360 degrees, but we have to reduce them to their equivalent of the acute angles that we have. All right, so let's move on to the second quadrant. So we are going to notice, guys, just like the previous case, in the second quadrant of the positive angles, we saw that our angle is what? Theta minus what? 180 minus theta there. That is 180 degrees minus what? Minus theta. So as of the positive here, it's under positive what? Positive angles. So we saw that our angle there is 180 degrees minus theta. All right, so it is the same thing that we are going to have, like the answers, they are going to be the same as of the negative angles. So as of the negative angles, our angle is what? We are in the second quadrant. Our angle is given as minus 180 degrees minus theta or minus theta minus 180. Any part that you might be given like that. So this is minus theta minus 180 degrees, or it can be minus 180 degrees minus theta. So what I'm trying to say is that when we add the positive, because we talked about these ones, the positive angles. Remember I said in our previous class, in the second quadrant, it is only sign there which we consider to be positive. Only sign here. So it's only sign which is positive. So it means the rest, cos is negative, tan is what? Negative. So we saw that we were going to reduce this angle that is what? A non-acute to an acute, because we need to change from non-acute to an acute. 180 minus theta, this one, it's non-acute. It's in the second quadrant. That's an obtuse angle. So only sine there is positive. We saw that sine 180 minus theta was going to give us the sine of theta. So this one is, guys, it's just a repetition. I talked about these ones. So cos 180, because it is only sine there which is positive. So cos will be what? Negative. Tan also is going to be what? Negative. We listed these in our previous class. So our case here is on these negative angles. What is going to happen, guys? Same way, as long you are in the second quadrant, whether it's a negative angle that you're talking about or it's a positive angle, it has the same properties there, because we are talking about an angle. The major concept here is we are talking about an angle which lies in the second quadrant. That's the major concept. The angle lies where? In the second quadrant. So what does it mean there? It simply means only sine is positive. So cos is going to be negative, tan is going to be negative, just like what we saw here, because it's the second quadrant. That is the those are the properties that you're supposed to understand about the second quadrant, third quadrant, fourth, and so on. So it means the answers that we had here as they are, those are the answers that we're going to have here for the what? For the negative angles, because we are in the same quadrant. The presentation only changed on how we are writing our angle, to say our angle is minus theta minus 180 degrees, because it's a negative angle. That's how it is written. But where it lies, if we are to simplify that value, it must give us the same thing as of the positive angle. So this is the concept. So it will remain as the sine of theta. So the same thing, if you're talking about a cos 180 degrees minus, now we are talking about what? We are on the negative angle, minus theta minus 180 degrees. Same as this one of the positive angles, which gave us what? Minus cos, because only sine there is what? Is positive. The same with the tan, minus theta minus 180. It is going to carry the same properties of that tan. So that's minus tan theta. So it simply means, guys, we're not going to waste much time, because it's going to follow the same way, same answers as we had previously. Same thing. So it simply means those answers that we had when we wrote about 180 plus theta, I want you to write the same answers for what? For theta minus what? 180 in the third quadrant. Same thing about the third quadrant. Remember, we listed all the reduction of what? Of 180 plus theta. You take those reductions, they are the same for this one in the third quadrant, theta minus what? 180. You move on to the fourth quadrant, your angle was 360 degrees minus theta. So I want you to take the same as it was when I did the positive angles. You take those reductions, you use them exactly for the minus theta. So what I'm trying to say is that in the fourth quadrant, it's only cos there, which is positive. It's only cos. So it means the sine is what? Negative. The sine of minus theta, sine there is negative. Cos only is positive. So it means the cos of minus theta is going to be what? Cos of theta. The tan of minus theta is going to be what? Minus tan theta, because it's only cos that we're talking about. So this is what? For the negative angles. As you can see, these are the same answers that you had when you were using positive angles, which is what? 360 degrees minus theta. The same answers, guys, that we had before. Remember, we're using 360 degrees minus theta for what? For positive angles. And these were the answers. Same thing. So I want you guys to go through this part, try to analyze the concept of these negative angles, how they can be reduced. We can simply use this concept to reduce them. This is about what? Reduction. But the same concept here of the negative angles is that we can change these negative angles. All right. You can convert or you can change. You can convert a negative angle. You can convert or change a negative angle to a positive. To a positive angle. How is that done? By using the concept of what? Equal angles. Use equal angles concept. Equal angles concept. Which concept is this? Which concept is this? Which makes a positive to be a negative, or which makes a negative angle to be a positive angle. Remember, I said two angles are referred to as equal if they are taken from the same point, but only the difference is on the direction, but they are taken from the same point. Remember, our angles, they are referred from what? The positive horizontal axis. This is how you take your angles, from the positive horizontal axis. So our angles, or these two angles, must be from the same point. So let's say I have an angle which is called minus 150 degrees. Okay? It's difficult for me to reduce this angle to an acute angle. All right. What can I do? I can simply convert it to its equivalent equal angle, which is a positive angle. It follows that, guys, from our concept of our quadrants, if one angle is positive, another one is supposed to be negative for equal angles. One is positive, another one is negative because of the direction. Let's say we are considering this one, minus 150. Definitely it's going to fall in this quadrant. Remember, it's going to be minus 90 degrees, minus 180. Remember, I said negative angles, guys, the direction, negative angles clockwise. So minus 150 is going to lie somewhere there. So let's say this is where we have what? Minus 150. Taken from the positive horizontal, from the positive horizontal axis, this is where we have what? Our negative 150 degrees. So you must know where it lies. So you were supposed to use this concept, all right, to say, okay, the acute angle is what? 30 degrees. So minus 150, where it lies. If I want to reduce, maybe that angle was given as sine minus 150 degrees. From the cast concept, we can see that, all right, that is our cast here. We can see this is the quadrant for a tan. So sine there is what? Is negative. So it was going to be negative sine of what? The acute angle, which is what? 30 degrees. Negative sine of 30 degrees. That is how you're going to simplify as an acute. It was a negative angle. You just knew the quadrant where it's going to lie because of what? This concept that we have here of our reduction. If you want to use this reduction, you can write as what? Theta minus what? Theta minus 180. How can we write as theta minus 180 this one? To have this 150 minus 150. In terms of our presentation, it means it is supposed to be theta minus 180. To have a negative, it means it is a smaller angle subtracting a bigger angle. Theta, the acute angle. So which angle are you going to put here so that if we say theta minus 180 degrees, we are supposed to get what? We are supposed to get minus 150 degrees. It's an equation, guys. We are back to N3 there. It's an equation because you want to know this theta. So you take this to the other side. So it was going to be positive there. So it means theta is equal to what? If we add 180, it was going to be 30 degrees. So this is our theta, which is 30 degrees. Remember from your reduction, we want to talk about the reduction here. I'm going to go back to my diagram. Don't worry. It was supposed to be what? Let's go to our reduction. Sine of what? Theta minus 180. It is the same thing as sine of theta plus 180 in the what? In the third quadrant. Sine there is what? Is negative. This is the quadrant of a tan. Sine is negative. So in actual sense, it was supposed to be minus the sine of theta. In actual sense. But we are not going to write like this. We are going to write as sine of what? Our theta is what? 30 degrees minus 180 degrees to get what? Minus 150. So it is equal to what? What is our theta? 30 degrees minus sine of what? Of 30 degrees. This is how you're supposed to have, just like this. You can have it like that. But we are saying that you want to avoid that reduction of using the negative angle as it is. You want to change it what? To the positive angles. This is where we are. So how are you going to have its equivalent? You're going to take, because we are saying an angle which is taken in the clockwise, it's negative. Its equal angle is the angle that is taken from the same point, but in the other direction or in the opposite direction. But from the same point, but in the opposite direction, this one. This angle is equal to this one. And as we can see, anti-clockwise, this angle is what? Positive. So what is this angle? You ask yourself the question now. Remember, angles here, they're supposed to form what? 360 degrees. So to find this one, we simply have to subtract 360 minus what? 150 degrees. That is the concept. That is the concept, to have that positive angle. So 360 degrees minus 150 is going to give us 210. That's 210 degrees. So it means this angle is 210 degrees. So I could have avoided using this negative angle, which is what? Minus 150, by using its equivalent. Guys, when I'm saying its equivalent, I'm saying these two angles are equal. I talked about this from equal angles. They're equal. Minus 150 degrees in its properties of the trigonometry is the same as 210 degrees, this one, as a positive angle. So if you want to avoid using negative angle, you can avoid that by using what? Its equivalent, positive. So we're just going to simplify sine of what? 210 degrees. Maybe you are used to positive angles because you know if this is a 210 degrees, it was taken from where? It was taken from the sine of what? 180 degrees plus theta plus to get 210. From 180 is what? 210 minus 180 degrees. So that was going to give us what? The same 30 degrees. So we are supposed to add 30 degrees here to get this 210. It's sine 180 plus theta. How are you going to reduce, guys, a positive angle, sine of 180 degrees plus what? Plus theta. 180 plus theta, it's a positive angle. Let's go back here. Let's go back here. 180 plus theta, yeah. It's a positive angle, that one. The concept is still the same. It lies where? In the third quadrant, where tan only is positive. So it means the sine is what? Is a negative. So our sine here was supposed to be negative sine of theta. Theta, the acute angle. Remember theta, it's an acute angle. But here we don't have theta. We have its equivalent value. What is the equivalent value of that theta, which we are saying it's our acute angle? It's what? 30 degrees. That's our acute angle. So it's minus sine of what? Of 30 degrees. The angle that is here in between here. That is the concept. As you can see, we are obtaining the same answer. Minus 30 degrees after reducing So it is up to you guys. Are you going to consider the negative angles from the concept of knowing them like this? You can reduce anyone by knowing this concept. Or you are going to change them to positive angles. By changing them to positive angles, it means you are going to use this part of your quadrant of the positive angles as we had in our previous class as it is, because you have changed these angles to what? To positive angles. It is in your hands. When it is like that, it will be in your hands. So that one, guys, it will be in your hands, like I said. So I want you to do as many questions using this concept. Try to apply it in your simplifications. So questions can also be direct. Sometimes questions can be direct. If they say rewrite like this type of a question, rewrite the following. Rewrite the following as a positive angle. This one, there is no way as a positive angle. This one, guys, there is no way. They want you to have it as a positive angle. So there is no way. You are supposed to know that concept. You see now, when it is like that, you are forced to know the concept. Let's say we are given the sign of what? Minus theta. So when they say as a positive angle, we are supposed to change that to a positive angle. This is supposed to be a positive. That is the concept. A positive equivalent to that angle. A positive equivalent to that angle. What is the equivalence? So this is the concept. So how are we going to take the equivalent of that angle as a positive? Because we need this angle to be positive. We go back. Either we are going to use this concept, or we are going to use this concept of what? The negative angles. Exactly. Remember, as of the negative angles here, we said these can be given sign of minus theta. It lies in the fourth quadrant. And that sign is what? Is negative. So it means we're going to have it as what? Minus sign of what? Minus sign of theta. It lies in the fourth quadrant, and in the fourth quadrant, sign is what? Negative. So that's sign of what? A positive angle, but it is negative in the presentation here. So it is our reduction then. We have reduced this one. Where is it that we are going to have that angle? Where does it lie? As a what? As a positive angle. So the reduction concept can be used. Where does it lie? So they can give us as like in terms of the angle, like theta, they can give us the numerical value. It depends. Maybe you're given the cos of minus 105 degrees like this as a positive angle. How can we express this as a positive angle? Where does minus 105 lies? All right. If we are to consider this one is a negative angle, so it is going this way. So it actually lies in the what? In the third quadrant. So this is minus 105. And we understand that, guys, this angle, where it is, the quadrant is for tan there. So cos is a negative. So it is either we're going to take it this way as a positive angle to change like the angle to be positive, then we reduce it. All right? Because it's the same thing. Or you're just going to ask yourself to say, which angle is here that is in between? This acute angle is the one that you're focusing. You know that your cos is lying in the what? In the third quadrant. So let's go back to our cast concept. In the third quadrant, it's for tan. So it means our cos there is what? Is negative. So it will be negative cos of what? The acute angle which lies here. So what is the acute angle? We can simply use 180 degrees minus this because this is 105. So subtract 180 degrees minus 105, that is 75 degrees, just like that. So it's going to be minus cos 75. So it is up to you guys, or you're going to have it properly presented as we had theta minus 180. the way that it is presented in that quadrant where it is, if it is supposed to be written in that manner, how are you going to have it? Cos of what? Theta minus 180 like this. We know that it is minus cos because of what? Where it lies. But we need to have it like this, theta minus 180, to get minus 105. What is the acute angle that you are supposed to put here? So if you don't know it, just use it as an equation. Theta minus 180 degrees is supposed to give me this angle. So what is my theta? I just have to solve it. It is equal to what? Minus 105. Minus 105, like this. So what is my theta? I can solve this theta by taking this to the other side. So it can be what? A positive 108. So adding this, we're going to get what? The same 75 degrees. So it means our theta is 75. So it was supposed to be written as cos of what? Theta, 75 degrees minus 180 degrees. So it is equal to what? If it was minus cos theta, so it simply means it's minus cos of what? What is our theta? The acute angle, 75 degrees. So this is it. So reduction, guys, reduction formula is in your hands. The way that you want to have it, it's in your hands. So let's do as many questions as we can. Try to work out from your question papers where the reduction formula is needed. It can be in terms of what? Positive or negative angles. So if you understand that everything, the presentation is the same, what is happening in the first quadrant is the same for positive angles and for negative angles. What is happening in the second is the same, the third and the fourth. So knowing one, you are done with everything. So this is it, guys. Till we meet again.